Question 1. Scenario. You need to ingest syslog data from a fleet of Linux servers and CEF formatted logs from a third-party firewall into Microsoft Sentinel, using the modern recommended ingestion method. The question is, which connector should you configure? Your options are: Option A, the legacy syslog connector using the log analytics agent. Option B, Windows security events via ARMA. Option C, syslog via ARMA, common event format, CEF, via ARMA. Option D, the Microsoft Defender for Cloud connector. Take a moment to think about your answer. The correct answer is C, syslog via ARMA, common event format, CEF, via ARMA. Why C is correct? Syslog via ARMA and CEF via ARMA connectors use the Azure Monitor agent with data collection rules for filtering and transformation, and are the current recommended method for ingesting syslog and CEF data, since the legacy log analytics agent is deprecated. Why A is wrong? The legacy log analytics agent-based syslog connector is being deprecated in favor of ARMA-based connectors. Why B is wrong? Windows security events via ARMA is specific to Windows security event log collection, not syslog, CEF from Linux and network devices. Why D is wrong? The Defender for Cloud connector ingests security recommendations and alerts, not raw syslog, CEF log streams. Question 2. Scenario. You configure the CEF via ARMA connector, but notice that only a subset of expected fields from your firewall logs are appearing in the common security log table, and the raw message field is oddly truncated. The question is, what should you check first to resolve this? Your options are: Option A, the data collection rule, DCR, transformation and the syslog daemon configuration on the forwarder for correct facility, severity and message length handling. Option B, whether Microsoft Defender for Cloud is enabled. Option C, the Sentinel Workspace's automation rules. Option D, the device group automation level. Take a moment to think about your answer. The correct answer is A, the data collection rule, DCR, transformation and the syslog daemon configuration on the forwarder for correct facility, severity and message length handling. Why A is correct? CEF, syslog ingestion issues typically stem from the DCR's transformation logic or the underlying RSYSLOG, syslog NG forwarder configuration, facility mapping, message length limits, which should be reviewed first for field mapping and truncation problems. Why B is wrong? Defender for Cloud status has no bearing on CEF, syslog field parsing from a firewall. Why C is wrong? Automation rules act on incidents after ingestion. They do not affect how raw log fields are parsed. Why D is wrong? Device group automation levels apply to Defender for endpoint remediation, unrelated to syslog, CEF ingestion. Question 3. Scenario. Your compliance team wants a centralized record of every resource creation, modification, and deletion action performed in your Azure subscriptions to be searchable in Microsoft Sentinel. The question is, what should you configure to ingest this data? Your options are: Option A, Windows security events via ARMA. Option B, Microsoft Defender for Cloud Apps connector. Option C, Threat Intelligence Platform connector. Option D, Azure Activity Log Diagnostic Settings sending data to the Sentinel workspace, potentially via Azure Policy for Scale. Take a moment to think about your answer. The correct answer is D, Azure Activity Log Diagnostic Settings sending data to the Sentinel workspace, potentially via Azure Policy for Scale. Why D is correct? Azure Activity Logs record subscription level management operations, create, update, delete. Configuring diagnostic settings to route him to the Sentinel workspace ingests this data, and Azure Policy can enforce this configuration automatically across many subscriptions. Why A is wrong? Windows security events via Armor captures OS-level security events on Windows machines, not Azure control plane activity. YB is wrong. The Defender for Cloud Apps connector ingests SaaS, Cloud App Activity signals, not Azure Resource Manager operations. YC is wrong. Threat intelligence connectors ingest IOC feeds, unrelated to Azure Resource Management logging. Question 4. Scenario. You need to enforce that Azure Activity Log diagnostic settings sending data to your Sentinel workspace are automatically applied to every new subscription created in your tenant going forward. The question is, what should you use? Your options are: Option A, an Azure policy definition assigned at the management group level with a deploy if not exists effect. Option B, a Sentinel automation rule. Option C, a Defender for Endpoint Device Group. Option D, a KQL scheduled query. Take a moment to think about your answer. The correct answer is A, an Azure policy definition assigned at the management group level with a deploy if not exists effect. Why A is correct. Azure policy with a deploy if not exists effect, assigned at the management group level, can automatically deploy diagnostic settings to new and existing subscriptions, ensuring consistent activity log ingestion at scale. YB is wrong. Sentinel automation rules act on incidents post-ingestion. They cannot provision Azure diagnostic settings. YC is wrong. Device groups are a Defender for Endpoint construct for managing devices, unrelated to Azure subscription diagnostic settings. YD is wrong. A KQL scheduled query analyzes already ingested data. It cannot configure ingestion pipelines. Question 5. Scenario. Your threat intelligence team has a commercial TAXII feed of malicious IP addresses and file hashes that they want automatically ingested into Microsoft Sentinel for correlation with analytics rules. The question is, what should you configure? Your options are: Option A, a custom log table with manual CSV upload. Option B, a threat intelligence TAXII data connector. Option C, the syslog via Armor connector. Option D, a hunting query bookmark. Take a moment to think about your answer. The correct answer is B, a threat intelligence TAXII data connector. YB is correct. The threat intelligence TAXII connector allows Sentinel to automatically ingest indicators from any TAXII2 X-compliant feed, populating the threat intelligence indicator table for use in analytics rules and hunting. YA is wrong. Manual CSV upload is not scalable or automated for a continuously updating commercial feed. YC is wrong. Syslog via Armor is for OS, network log ingestion, not structured threat intelligence indicator feeds. YD is wrong. Hunting query bookmarks save investigation results. They are unrelated to automated IOC feed ingestion. Question 6. Scenario. A custom application generates JSON-formatted audit logs that have no built-in Microsoft Sentinel data connector, and you need this data queryable in a properly typed table for KQL analysis. The question is, what should you create? Your options are: Option A, a Sentinel playbook to convert the logs to CEF format. Option B, a workbook to parse the raw text at query time only. Option C, a custom log table using a data collection rule, DCR, and the logs ingestion API. Option D, a Microsoft Defender for Cloud Apps custom app connector. Take a moment to think about your answer. The correct answer is C, a custom log table using a data collection rule, DCR, and the logs ingestion API. YC is correct. You can create a custom log table in the workspace and use a data collection rule together with the logs ingestion API to ingest and properly schema-type custom JSON data, making it fully queryable via KQL. Why A is wrong. Converting to CEF via a playbook is an unnecessary and non-standard workaround compared to native custom log ingestion. Why B is wrong. Parsing raw text only at query time, e.g., with parse operators, is inefficient at scale and doesn't create a properly typed, indexed table. Why D is wrong. Defender for Cloud Apps connectors are for discovering and governing SaaS application usage, not ingesting arbitrary custom application logs. Question 7. Scenario. You are troubleshooting why a newly created custom log table is not receiving any data despite the data collection rule appearing correctly configured and the log's ingestion API call returning a 204 success response. The question is, what should you check next? Your options are: Option A, whether the Sentinel workspace has UEBA enabled. Option B, whether RSA rules are in audit mode. Option C, whether the workspace has automatic attack disruption enabled. Option D, ingestion latency, data can take up to 15+ minutes to appear, and that the DCR's stream declaration matches the table schema exactly. Take a moment to think about your answer. The correct answer is D, ingestion latency. Data can take up to 15+ minutes to appear, and that the DCR's stream declaration matches the table schema exactly. Why D is correct. Even with a successful API response, data can take time to appear due to ingestion latency, and mismatches between the DCR stream schema and the destination table schema are a common cause of silently dropped or delayed data. Why A is wrong. UEBA affects behavioral analytics on existing data. It has no bearing on whether a custom table receives ingested data. Why B is wrong. RSA rules are a defender for endpoint protection feature entirely unrelated to custom log table ingestion. Why C is wrong. Attack disruption is a response capability, unrelated to whether custom log data lands in a table. Question 8. Scenario. Your SOC wants Microsoft Sentinel to automatically flag when a user account signs in from a location and at a time that significantly deviates from their established baseline behavior, without writing a custom KQL rule from scratch. The question is, which analytics rule type should you enable? Your options are: Option A, an anomaly detection rule, built-in machine learning-based anomaly. Option B, a scheduled query rule with a fixed threshold. Option C, a near real-time (NRT) rule. Option D, a threat intelligence-based analytics rule. Take a moment to think about your answer. The correct answer is A, an anomaly detection rule, built-in machine learning-based anomaly. Why A is correct. Sentinel's built-in anomaly detection rules use machine learning models, UEBA-driven, to establish behavioral baselines per entity and flag statistically significant deviations, such as unusual sign-in times or locations, without manual threshold tuning. Why B is wrong. A fixed threshold scheduled query requires manually defining static conditions and does not adapt to individual user baselines. Why C is wrong. NRT rules provide faster, near real-time, execution of scheduled style logic, but are not inherently behavior, anomaly-based. Why D is wrong. Threat intelligence-based rules match data against known IOCs. They do not detect behavioral deviations. Question 9. Scenario. After enabling an anomaly detection rule, your SOC is overwhelmed with anomalies triggered by a legitimate but unusual monthly batch job that runs from an unusual IP range. The question is, what is the best way to reduce this specific false positive without disabling the anomaly rule entirely? Your options are: Option A, disable UEBA across the entire workspace. Option B, delete the anomaly rule template permanently. Option C, duplicate and customize the anomaly rule to adjust its sensitivity or exclude the known service account, IP pattern. Option D. Set the analytics rule to run only once per year. Take a moment to think about your answer. The correct answer is C. Duplicate and customize the anomaly rule to adjust its sensitivity or exclude the known service account, IP pattern. Why C is correct? Built-in anomaly rules can be duplicated and customized, allowing you to tune sensitivity thresholds or add exclusions for known legitimate patterns like a scheduled batch job, while keeping the rule active for genuine anomalies. Why A is wrong? Disabling UEBA workspace-wide removes behavioral analytics entirely, losing detection value across many rules, not just this one. Why B is wrong? Deleting the rule template entirely removes the detection capability rather than tuning it. Why D is wrong? Reducing run frequency to once a year would severely delay detection of genuine anomalies, defeating the rule's purpose. Question 10. Scenario. Your SOC wants to visually assess which MITRE ATT and CK techniques are covered by currently ingested data sources versus which techniques have no supporting data at all, before writing new analytics rules. The question is, what should the SOC review? Your options are: Option A, the Incident Severity Distribution Report. Option B, the MITRE ATT and CK coverage view showing data connector and analytics rule mapping to techniques. Option C, the Playbook Run History. Option D, the Threat Intelligence Indicator Expiration Report. Take a moment to think about your answer. The correct answer is B, the MITRE ATT and CK coverage view showing data connector and analytics rule mapping to techniques. Why B is correct? Sentinel's MITRE ATT and CK coverage view maps both active analytics rules and available data sources to ATT and CK techniques, helping teams identify true coverage gaps, no data, versus rule gaps, data present but no detection. Why A is wrong? Incident severity distribution shows volume, severity trends of past incidents, not underlying data source or technique coverage. Why C is wrong? Playbook Run History tracks automation execution outcomes, unrelated to ATT and CK coverage assessment. Why D is wrong? Indicator expiration reports track threat intelligence data freshness, not detection coverage across ATT and CK techniques. Quiz complete. You have reviewed all questions and their full explanations. Great work. Please like and subscribe my channel for more such contents.